Today we are going to be talking about macromolecules. If you can't tell by the big name, they're pretty important. Macromolecules allow for life to take place. Without them, no living organisms would be able to survive. So, what are they? Let's get into it. Macromolecules are large, organic, meaning they contain carbon, molecules. Now that is really important to remember, that organic molecules contain carbon. So, macromolecules come in 4 different varieties. These are carbohydrates, lipids, proteins, and nucleic acids. Now, you may be thinking, wait, carbohydrates? Like carbs? And lipids, aren't those fats? Which they are, in case you didn't know. Aren't we supposed to avoid carbs and fats? If you are thinking this, you aren't completely wrong. Carbs and lipids are indeed macromolecules, but they aren't bad for you. In fact, they are necessary for your survival. Like anything else, they're good for you in moderation. But we'll get to that later. For now, let's stay on the topic at hand. Let's first look into basic macromolecule structure. So, what are macromolecules made of? Well, all 4 varieties are primarily made of carbon, oxygen, and hydrogen. Now, proteins and nucleic acids also both contain nitrogen. And nucleic acids contain phosphorus. So, just remember, all 4 types contain carbon, oxygen, and hydrogen. The last 2, proteins and nucleic acids, also contain nitrogen. And nucleic acids only contain phosphorus. So, now that we know what the ingredients are, per se, for macromolecules, we need to look at how they're arranged to form macromolecules. To know that, we first need to know a few things. One of these is that macromolecules are polymers. What are polymers, you might ask? Well, to understand polymers, we must first look into monomers. Monomers are molecules, to put it simply. They are one single molecule. These molecules then all link together by means of covalent bonding to form polymers. So, they both end in mer. But mono means one, poly means many. Remember that. You can look at it this way. You're building a Lego house. Each different kind of Lego brick and piece is a monomer. Combine them all together and you get a house, or in this case, a polymer. It is still a Lego. It is not changed to some other random toy type like some off-brand Lego. So, now that we've looked at basic macromolecule structure, let's look at our first macromolecule, which is carbohydrates. So, what are carbohydrates? Carbs are one of the most fundamental sources of energy for all living organisms due to the fact that they're really, really good sources of immediate energy. So, you may have heard some people talking about carb loading before some big athletic event. Well, why do they do that, and what is carb loading? Carb loading is eating a lot of carbs before you're going to be doing something that requires a lot of energy. So, why do people do this? Because carbs provide you with energy. Now, fats also provide you with energy, and we'll get to that later, but they provide you with long-term energy storage, which we will also discuss a little bit later in the video. Carbs can serve as an immediate source of energy, being broken down as you need them, and running through your digestive system and body to fuel you for whatever you're doing. So, now that we've covered that, we need to look at some other things carbs do. One of these is making up the cell walls of plants. Now this is really, really, really important. So, carbs most commonly take the form of sugars. The monomers of carbs are called monosaccharides, like monomers, just saccharides on the end instead of mers. A little more complicated of a word. Monosaccharides are more commonly known as simple sugars, which I'm sure you've heard of before. Glucose is a simple sugar. Fructose is as well. Guess what happens when you combine glucose and fructose? Sucrose, a polymer. The polymers of carbohydrates are called polysaccharides. Get it? Polymer, polysaccharide. That poly is still in there, so many. That's what it means. So, sucrose, as mentioned, is a polysaccharide. Now, what is sucrose, you might be thinking? And why am I so excited about it? Well, that's because it's more commonly known as table sugar. See why I'm excited now? We have a real-life connection to what we're learning about. This helps make it easier to understand. So, anyways, there are some other important polysaccharides. Some of these include lactose, starch, glycogen, and cellulose. Now, two of these should sound really familiar. Number one is lactose. This probably sounds familiar to you due to hearing about people who are lactose intolerant. You're probably thinking, doesn't that just mean they can't have milk? In which case, you would be correct. But have you ever stopped and wondered, why can't those people have milk? Well, here's your answer. They can't digest it due to not having a sufficient amount of an enzyme known as lactase. Remember that for later. It's going to be really, really important when we talk about proteins. So, anyways, the second polysaccharide that should sound super familiar is starch. Starch is primarily found in plants and is also a great source of energy. To understand why, though, we first need to understand what happens when edible polysaccharides are digested by living organisms. When these polysaccharides are digested, they're almost 100% of the time broken down into glucose. Remember him? He's like the king of simple sugars. Here's why. He can be easily used by our body in multiple different ways. Glucose can be immediately used as a way to get energy, or if you don't need that energy right away, it can be stored as glycogen, or, wait for it, fat. Glycogen is like the middle ground of energy storage. It isn't used right away, but it also isn't stored for as long as fats are. So, anyways, the reason starch is so great is because it is literally a giant chain of glucose. This means it serves as a great source of energy, especially immediate energy. This is because it releases more and more energy over time, as each glucose molecule is tediously broken down one at a time. Oh, and one more really important thing about carbs. You may be stressed out by all the different kinds of carbs there are, and you may be struggling to remember what a carb is and what isn't. And if you aren't now, you will definitely be later. Well, a neat thing about carbs, at least some of the sugars, but most of the variety of carbs, is that they almost always end in the suffix OSE. I'll write that down. Carbs